Hello, and welcome to Backer Breaks It Down. In this episode, we continue looking at the law of signs, specifically the ambiguous case. This episode will feature a no triangle situation and an only one triangle situation. So in our previous video, we talked about how the ambiguous case with the law of signs is when you are given two sides and the angle opposite one of them. Now, when this happens, it is possible that two triangles could be created, which is what we saw in the last video. It's also possible that there might only be one triangle or no triangles, right? And so the way we figure this out, are there two, one, or none, is we just pretend that there's going to be two of them. And we go about using our law of signs, and whatever happens, happens. I know. Anywho, so when I see that I'm given one angle and two sides, I know this is the ambiguous case. So I want to start off by labeling my two triangles with the given information because I'm literally pretending that there's going to be two triangles. Okay. Now, I know this is the law of signs because I do have the buddy system. I'm given angle B and side B. And so I'm able to create my buddy system ratio. And so that's going to look like this, where I have sine of 61 degrees over 8. Now I can use the law of signs to find the measure of angle C since I know the measure of side C. So this is going to be equal to sine of angle C divided by side C, which is 21. So then I go and I do the usual math. I'm going to cross multiply. So I'm going to end up with 21 times sine of 61 divided by 8. And this is going to give me sine of angle C. So I'm going to calculate what the decimal is, and then I'm going to take the inverse sign of that decimal. So to the calculator. So I got 21 times sine of 61 divided by 8. And now I'm doing the inverse sign. So second sign of that answer. Oh no, I got an error message. So what does this mean? This means that there is no triangle. Okay, so your calculator will literally tell you when there's no triangle because you'll get an error message when you go to do the inverse sign. So that was simple, right? Yeah, all right. Now let's take a look at one more example, okay? So once again, I'm going to label both triangles with the given information. I know that angle C is 70 degrees, side B is 9, and side C is 14. So I've got my buddy system because I know angle C and I know side C, so I can create my law of signs buddy system ratio. So I'm going to have sine of 70 degrees divided by 14. And clearly, the only thing I can use this for at the moment is to find angle B. So sine of angle B divided by 9. So then it's time to do the necessary math, meaning I cross multiply and divide. So I'm going to calculate 9 times sine of 70 divided by 14. And this is going to give me sine of angle B. And then remember, I have to use the inverse sign to find the angle. So calculating 9 sine of 70 divided by 14. Inverse sign of that decimal, and I get that the measure of angle B is equal to 37.2 degrees. So I actually got an angle measure here. So I definitely have one triangle. But remember, I'm supposed to pretend like there's two triangles. I just want to go back to this diagram here that shows that like there are two possible angle B's here. And you'll notice that they're supplementary. So these two angle B's add to be 180. So that's what I'm going to do with my two possible angle B's. Okay. The second angle B, the second angle B here is equal to 180 minus the measure of the first angle B, which was 37.2. So I get 142. 142.8. So then I go about finding angle A in each triangle, using the fact that all three angles add up to be 180. So in the top triangle, I get that angle A is 72.8 degrees, which is totally realistic. There's definitely one triangle. In the second triangle, 180 minus 142.8 minus 70, I get a negative angle measure, negative 32.8 degrees. And that just doesn't make sense. So do you know what that means? That means there's not a second triangle. There's only one triangle. If you don't get realistic angle measures, how can you have a triangle? You can't. So that means I'm just going to finish solving the top triangle. I'm going to use, let's see, well, I can use that buddy system ratio, but I think I'm going to go with the one that we were given. And we were given the sine of 70 over 14. So I'm just going to use that one more time. Let me just create some space here. But this time I'm going to use it to find side A, because I don't know what side A is. So I should probably find it. So I've got my buddy system ratio, sine of 70 over 14. I'm going to use that to figure out what side A is, because as you can see, I don't know what it is. So that gives me sine of 72.8 degrees divided by side A. And so then I do the usual math where I cross multiply and divide. So I'm multiplying 14 sine of 72.8, and I'm dividing that by sine of 70. And this calculation will give me side A, which is what I'm still missing. So 14 sine of 72.8 divided by sine of 70. I get that A is 14.23 units long. And thus I have solved this triangle, and there's only one triangle. So the ambiguous case with the law of sines is when you're given two sides and the angle not between them. This is the ambiguous case, which means there could be one, two, or no triangles possible. You should proceed with caution, but pretend like there are two triangles. Your calculations will tell you whether or not there are two, one, or no triangles possible. And that's how Bakker breaks it down.